Assalamualaikum, my name is Norin Asna binti Azmi. So I will present on the introduction. The traffic engineering is an area of civil engineering concerned with the safe and efficient flow of people and products on roads. The basic goal of traffic engineering is to achieve free and quick flow of traffic with a minimum number of accidents. The intersection location should be assessed continuously for traffic engineering consistency. So the purpose of this study was to determine the issues with traffic flow at the signalized intersections near Parit Bota during peak hours and to evaluate the related quality of service. So the objective of this study is to analyze traffic flow at the signalized intersections, to analyze geometric and traffic data for performance evaluations, and to propose effective improvement for traffic flow. For problem statement, the traffic congestions in Malaysia is thought to spend an unbelievable 1 million hours every day because of the country's high daily car usage. So the primary source of concern is the lack of capacity in the current infrastructure relative to the number of traffic, which is particularly noticeable at urban intersections. So in order to solve this problem, an efficient traffic control techniques including traffic signals is crucial.
Assalamualaikum, my name is Nurizai binti Zulkifli. So here I want to present about the tools and equipment preparation during our site visit. So the project was carried out at one of Ayitam signalized intersection within Jalan Keluang and Batu Pahat. Several tools and equipment are required to execute the project adequately. So the tools we bring with is odometer or measuring wheel, stopwatch, analog counter, and safety vest. Next is the procedure. So first of all, the traffic movement count is conducted on approaches for 55 minutes in three segments of 15 minutes located at Air Hitam, Johor. Then the data was recorded. Number two, the lane width W in meter for all approaches were measured and recorded. Number three, the green light G in second and cycle time C in second for each phase were measured. Number four, the traffic volumes were converted to the passenger car units in PCU. This is the design flow Q PCU per hour. So number five, the adjusted saturation of flow S in PCU per hour was calculated and transferred for each approach. Number six, the Y value, the total value of Y for each approach, was determined by computing Y, the ratio of design flow to adjusted saturation flow. Next, number seven, the integrin time T in seconds and total time loss per cycles L in second were determined. So number eight, the intersection's practical capacity Y practical and reserve capacity RC were determined. And last but not least, number nine, for each approach, the average stop delay per vehicle D in second and level of service LOS was calculated. Thank you.
Next, we go to result data presentation. We take the signalized intersection between Jalan Keluang 1 to Jalan Keluang 2 and Jalan Parit Bota. We take it at 12 June 2024 on 5 p.m. to 6 p.m. for about 60 minutes. For the data from Jalan Keluang, we got a class of motorcycle, class 1, which is we go 125 for going through, 300 for cars for going through, for van and medium trucks for 36 for going through, and class 4 heavy trucks 24 for going through, and make it total 485. And at the same time from the through lane 2, 53 motorcycle, 421 for cars, and van and mediums for 12 and make it 513. And the right turn, the maximum is class 2, which is cars 157, and the low one is the heavy trucks, which is 0 and make it 194. For Jalan Parit Bota, we got the higher class 2, which is 187 for the right turn and make it all 230 total. And for the left turn, we got 174 for cars 2 two of a medium trucks and van and make it 250, which is plus a motorcycle, which is 74. Last is Jalan Keluang Dua. We get from the right lane to the left lanes, we get a through lanes, 121 for motorcycle, and class 2 cars, which is 32 for through, and 6 for van, and 7 we got heavy trucks, which is make 166 going here through, and maximum is class 2, which is cars 380, and the minimum class is class 4, which is 21 of heavy truck and buses, which is making 480. For the left turn, we got the maximum class 2, which is cars. We have 93 cars and 0 heavy trucks, which is make it 167. For the data of the width of the lane, which is the JT1, we got 3.5 meter. JT2, we get 3.5 also. J1, which is Jalan Keluang 1, 3.5 meter also, and Jalan Parit Botak, which is 4 meter. And the left turn of the lane of the Jalan Parit Botak, which is 4 meter also.
So this is the manual calculations for this project, which is we use the PCU factor. So for the class 1 is for motorcycles, class 2 is for cars, class 3 is for van and medium trucks, and class 4 is for heavy trucks and buses. So with this PCU factor, we times it with the number of cars that use the road for the time that we have investigate. So then we will get the total cars, and then we get the total directions for all west, south, and east. And as for the calculations for the determination of saturation flow, so we have 3 approach: west, south, and east. So for each approach, we need to know the S that will be times with the factors of the road. So the width of the road can be determined, which is from the approach west, we use 1885, which means that the width of the road is 3.5. So for the approach south, we use 1965, which is 4.0 meter, and for east, we use 1885 and 1965, which is 3.5 and 4.0 meter. Then we times it with the factors to get the saturation flow, and then we will get the saturation flow determinations result.
So next is the calculation of the total of y. So the total of y obtained is 0.9602.
Now I will explain the ways to determine average delay per vehicle, which is D, and also how to calculate the level of service, LOS. So I will use the formula that is given to calculate the D, and based on the calculations, I got level of service for the phase 1 is D and also E. For phase 2 is D. For phase 3 we have C and also D.
After we determining the LOS or level of service, we need to also determine the maximum Q or N using the equation of N equal to QS times R over 2 plus P. After we did the calculation, the value of N was obtained as shown in the table. Determining the maximum Q or N is important because this measure is crucial to understand and to manage the traffic flow, as it will also help to assess the traffic congestion, designing infrastructure, optimizing traffic signals, and also the planning and simulation.
For the discussion and conclusion, Data collection for intersection design is limited due to varying lanes and roundabout capacity. TTV receipt software may not be entirely accurate due to signal disturbances. Enhancing traffic flow and coordinating signal timing can reduce operating costs.